Hello guys, in my last video we were working on a Chevy pickup truck where they had a misfire due to a incorrect gap on the spark plug, and we used a second ignition waveforms to find the misfiring cylinder and to figure out why it was misfiring. Many of you guys showed interest in that video, and I'm so glad that many of you guys actually asked the question, you know, what equipment I'm using, how I'm setting up my equipment, what scope I'm using, and all that kind of stuff. So instead of answering each question, I decided to actually make the second video, which I can actually explain better. You can guys see what I'm actually doing. Now, to get a second ignition waveform, you got to have some kind of equipment, and back in the days it was so much easier with the engines with a distributor. You can just get your ignition probe on your spark plug, and you get your waveforms, all of the versus 4, 6, 8, 12, 10 cylinders, doesn't matter. And then you get your firing order, and you can actually set your scope, and you can actually see each individual cylinder. Now from the second ignition waveforms, I mean, the sky is the limit how much you can actually read from each of those. You can actually figure out, you know, type of the mix you have in the cylinder versus do you have a lean or rich mixture. You can figure out if you have a compression issue. You can figure out if you have ignition issue. And I mean, literally sky is the limit how much you can decipher from those waveforms. By no means I'm not the expert on it, but every time I have an excuse, you know, to use my to use ignition waveforms as analysis, I do it, and you know, more you do, you better you're gonna get. So let's get to the equipment. If my suspect is ignition, anyhow, it doesn't really matter what kind of a misfire it is. If I'm having a misfire in the engine, now this is actually more beneficial if you have a intermittent misfire, where many times actually power control module which misidentified the cylinder, which was actually the case in my last video, where actually computer was flagging the code on 2 cylinders. It was number 5 and number 4, but we only had a misfire on number 5. But the reason why it was flagged on number 4, because that was the firing order. I don't remember, but I know it was at 5 and then 4. So computer couldn't really decipher which cylinder is, you know, misfiring the most, and that was actually flagging the code for both of them. We were looking at the misfire counter. We could see that we were having misfires on 4 and 5, and for that reason, you know, having a second ignition waveforms, it's so much more easier to find your misfiring cylinder. Now, that being said, I'm gonna go to the first question, and the question is, I can never get the ignition waveform on the screen, and the reason why is that it's not as easy as it used to be. That's number 1. Number 2, depends of your equipment, depends of your scope. Yeah, anyway, any scope can do it, but some higher end scopes are so much easier to deal with. It's so much easier to capture the waveform that you need to. And also how accessible the ignition coils. Now, as I say, as you guys know, nowadays we don't have a distributor anymore. Everything is a coil on plug or coil neo plug systems. So many times you cannot physically get to the coils that can be covered by intake manifold, and they can be kind of sharp angled, and it's difficult to get to each coil. And that being said, it's more difficult to get a ignition waveform. The best is to get all of them lined up, so you can actually pretty much just go as a looking for the oddball and find your problem. Now, what I do first, if I have a misfire, I always go with my Pico second ignition probe. Is this one. This is designed for a single cylinder, and you pretty much go to, you know, start the engine, and you just go from one cylinder to another. You place your probe until you get your waveform. Now, many times, something else also, pretty much every manufacturer is going to, now, like the waveform from the Chrysler versus a GM or Ford or BMW, they're all going to give you different waveforms, meaning by the amplitude of the waveform, the strength of the waveform, and noise and all that kind of stuff. But one thing that we can always rely is the burn time. The again, due to the fact of for different coils, you know, you might have different power kV, or you may not be able to see your dwell time or a spark kV, but you always should be able to find your burn time, and that's what actually we can look when we look these Misfire. It would be nice to have a full waveform. Unfortunately, many times we cannot do that. We don't see it anymore. Now that depends on the type of the coil. That depends of the you know, how accessible the coils are, how insulated coils are. You might have a OEM and a aftermarket coil. With the aftermarket, I've seen many times, they insulate more than an OEM, and you put your probe on the same place and your waveform is different, smaller basically. Your amplitude is smaller. You would think you might have a problem, which you don't. Basically, it's just the, you know, the coil is more insulated, and so that can be a problem. And you know, that just comes with experience. More you do, you know, more you're gonna see those, like anything on the scope. You know, the first time you see the waveform, you see all these glitches and lines and whatnot, interference from the ignition. You know, there's a lot of noise under the engine, a lot of current, a lot of wiring and stuff. And then every time you see some kind of a line on the waveform, you think you have a glitch, like looking for something, maybe, I don't know, crankshaft position sensor signal or something, you know. But that kind of goes along the side with the ignition as well. You know, you just kind of learn, you know, as you go. So anyhow, when I have a misfiring engine, I would go with my probe, and I would place, you know, where I can on the coil, and then once I get my waveform on the screen, I will set my trigger, and then I would kind of go around the coil to find a best spot, kind of sweet spot where my signal is the best. Now, once you find that spot, you're gonna go to next cylinder, but you want to keep your probe in the same spot. You don't want to put coil on, like on the top, if your first waveform that you looked was here on the side. So you always want to be in the same position if you can, of course. If it's, you know, many times you can't, again, just because of this, you know, type of the coil or how the engine is designed. It's getting more and more difficult to get second ignition waveforms. That's why not many technicians are going that route, because it's really a hassle. But for some cars like these GMs, they have like a coil meter plug system, and there's tons of these cars on the road, and it's very easy to actually get the waveforms on these cars. So this would be my first choice if I'm looking for ignition rate, you know, when I'm looking for the Misfire. And I'll show you guys. Basically, this one has a BNC connector. I'm going to connect it to my picoscope, and then we have this ground clip. You're going to clip it to the block of the engine to protect your scope, which leads me to another question, which says, do we need a attenuator when we are getting a second ignition waveforms? And the answer is no, we do not need attenuator, because our voltage is nowhere near that's going to damage the scope, and we're actually going to measure the voltage that we're getting, you know, from our pedal. However, what we have to make sure is that in case that our coil or spark plug wire has opened and it can actually jump, you know, find a ground path out of the, you know, not through the spark plug, and actually ended up into your scope, and you're talking at 15 to 30,000 volts, and it's going to fry your computer or your scope. So in order to avoid that, it's very important to have a good quality equipment that has a inside your cable is actually, it could be a diode or capacitor that's going to actually protect your equipment from those sudden, you know, spikes in voltage. Again, that only happens if you have a crack insulation on your coil or crack in your spark plug wire. So you do want to protect your scope. There's a risk that you can, you know, that can happen, but if you have a good equipment, you're safe. You want to clamp, you got to make sure that your lead is safely grounded on the block of the engine or on the body of the car. I generally don't like to use the battery ground, I mean the battery ground, but you can, but just the block is fine. So that, from that perspective, you really want to make sure you protect your scope. You've got to have something to some kind of, you know, cable that will protect your scope. So this is, you know, designed by Picoscope and it works great. Now, if I'm getting multiple cylinders, you know, then you have to have some kind of a probe that can actually pick up the multiple firing events from all of the coils. Depends if you have 4, 8, 6, 12, doesn't really matter. The equipment that I use is a snap-on ignition paddle or probe or bar, whatever it's called. And so this is the, I'm not sure, it's see, EAP019. I'm not sure if that's the, let me see. I think that's it. So this is the probe that I'm using. I think this is the number. They're like $50 on a Snap-on website, and so they are designed to actually to be laid on top of the coils. You just lay it straight on the coils, and you will be able to pick up all of the waveforms, and then you're gonna get it on the screen and set up your scope and your inner trigger, and then we're gonna use a second channel to get our ignition waveform to be able to, not ignition, I'm sorry, to get our firing order in order to find a misfiring cylinder. Now, along with these, I also have homemade paddles. So basically, this is nothing but a copper. That's all it is. It's a conductor. So how this works? Every time we have a current flow, we're going to have a magnetic field. And this time we're talking about secondary current flow, okay? And by placing some of these probes are nothing but the conductors. So when you have a magnetic field and you have a conductor, you're going to induce some kind of voltage. And that voltage is basically our ignition waveform. That's all it is. Now, on my, I will leave the link in the description how I made these homemade probes. I'm not selling these. They're a long process to make them, but if you want to spend some time, they are really useful. Now, they're both have kind of like between the Snap-on and my, they are like I purposely made 3 different sizes because I wanted to have something for 6-cylinder engines or 4-cylinder engines. Now, the downsides of these are very thick metal, and they're not malleable. These ones actually are thin, and you can actually slide them underneath the intake manifold if your coils are covered by intake. Now, problem with these is they're too light, and they tend to kind of slide off the coil. Something else, some other variables with this is that, you know, every time if your probe is not laying down on the coil all the way, if you have some kind of a gap, if it's pushed up just a little bit, sorry guys, you're gonna have a your signal on that coil is gonna be lower. Again, your burn time is gonna be the same, but your KV is gonna be a little lower. So you might think that you actually have a problem with that coil. You don't. You just have your probe is not sitting all the way down. Sometimes it's pretty much impossible to you know, put them all the way on the coils, and that's, you know when you're trying to get these waveforms, you know, it's not always easy, but for some engines it's not. As I said, on these ones it's pretty simple. So that's another variable you have to, again, that all comes from from experience, you know, looking at your noise, looking at the you know, how you position your probes. Now, something I want to do with these, I actually have 4 of these, and eventually I'm gonna, once I get to the engine that I'm having a problem with, I'm gonna actually trim this down. I'm gonna cut them, and I'm gonna insulate the end of it so I can actually use it on V6 engines. My plan is to use these on those engines where you have you know, coils covered by intake manifold. Now, okay, so let's get to the like a basic setup, you know, the wiring. The single probe, as I said, it's a pretty self-explanatory, nothing to it. You have one lead, and you plug into your scope, and your second lead. There you go. No, I got something else I have to talk about. So again, a BNC connector straight into the scope and your ground wire. And that's about it, it's nothing else to it. Now, your second channel has you gotta be able to have two channel scope. Okay, so the first one is going to be your waveforms. Now, if you're using a single, you don't have to worry about. You just have one ignition waveform. You're going from one cylinder to another, and you're done. Now, when you're doing a multiple cylinders, you got to be able to find your sink. What cylinder you're going to use, it doesn't really matter. Number one would be the easiest one to do it, and then you need to have a second channel to get your sink. Now, in order to get your firing order from that sink, like I don't know, you have cylinder number one, you have a six-cylinder engine, and the firing order is 1, 2, 3, 4, 5, and 6. You start from number one, and then you just go from one initial waveform to another, and you're looking for one initial waveform that doesn't look right. So, and then you're gonna say, okay, 1, 2, okay, number 3 doesn't look right. So that's your sink. Now, how are we gonna get the sink? What to do? What kind of equipment we need to actually to get the sink from that coil. Now, if you have a coil, a 2-wire coil, where this is the Chrysler, where this is a 2-wire coil and it has a constant power, and ground is actually comes from the power control module, and all you gotta do is just to back probe that wire, and you're gonna actually get a primary ignition waveform. Now, in that case, you got to use attenuator if your scope it's not able to handle 100 volts or more. And so that's going to be your sink. So that's one way to get a sink. The second way is, actually to get your current clamp. And now the problem is, more and more coils are now 3 or 4 wire coils. They actually have a transistor inside of the coil. No, it's no longer, transistor no longer is in a power control module, so you cannot get a primary ignition waveform. In that case, you get pretty much actually two options. You can actually get a current clamp and get your current clamp over the you get a current clamp and you clamp it over your power or ground. Each one of those wires is going to give you a current, and then you're going to be able to, it's going to be like, the waveform is going to look like this, basically. Okay, so it's going to be your current on that coil, and then okay, this is the current from cylinder number one, and then you're going to find again, like after 6 ignition events, you're going to see that current again. So that's going to be your 720 degrees of crankshaft rotation, and that's how you can get sync as well. And the third, which is my favorite and most easier way to do it, is basically use my single coil on plug probe, and I'm just going to put it on the coil, and 2 seconds, put it on the coil, I got the sync. I don't have to worry about back probing my wire, piercing wire, whatever. If I have another probe, I can do it. Now, this is a very nice probe. I love it just because you can actually bend it. You can twist it, bend it. It's a perfect for now. Something else also I have is this one. This is an OTC one, and it's not, again, the quality of the waveform is the same. This is one I have. This one is kind of a little stiff, but this has a short wire, and that's kind of pain in the ass. But this lead is actually kind of short. However, you can see that this one also has a ground lead, so you gotta have something to protect your scope in case that you have broken insulation of your coil or wire. All right, so that's for the single. Now, what do we do in order to set up your multiple probe for multiple cylinders? And again, so this is the setup that I'm using. Again, I can use the snap-on original, I can use my homemade, doesn't really matter. Now, and this is just the way it's designed. I mean, it's so I kind of have to walk around that. So you can see that each of these pedals or probes, they have an RCA connector. Okay, so you can actually use 2 channels. You can get the waveform from bank 1 and then put it on one channel. You can and then the waveforms from bank 2 on the second channel. Then you can have actually the third channel for your sync. It doesn't really matter, but whatever you want to do. I like it just to put it all on one channel to get all of my waveforms lined up. So now in order to, so the next step is just to, like a nuts and bolts, you know, you have to put these two leads together. So I'm just going to use a splitter, 2-to-1 splitter on the RCA, which I had it somewhere. Okay, it's nothing, just get it off of Amazon, nothing special about this guy, just a little adapter. So I'm gonna connect these two together, and then I have a single lead, okay, the single lead, and I'm gonna hook it up to my scope. So I'm gonna combine all of these ignition waveforms into one channel. All right, now the next step is, what am I gonna use to protect my scope? I still have a problem if I have a, you know, if my second ignition waveform sparks and it goes to this guy and fries my, you know, I'm sorry, I'm just blubbering too much. So anyhow, I need to have another lead to convert this RCA into the BNC or banana connector, which depends what scope I'm having. And for that, I'm using a snap-on ignition cable. I'm using snap-on ignition cable, this one here. And this one actually has a, I don't know, does it have a, let's see where it's at, I think it's in here, yeah, it's in here, inside of this guy is a capacitor or some kind of a diode. I'm not sure exactly what it is, but my point is, it has a protection. It will protect my scope in case of the spikes of voltage. And now you can see one side is banana, one is RCA. I'm going to plug these two together, and now I have a single lead that I'm going to connect to my scope. If you're using a Varus or any other scope that has the banana adapters, you're done. Nothing else you need to do. In my case, I have to convert now this one into the BNC, and then this is just a simple another adapter, and I'm going to plug it in like so. And this is your complete setup. Everything is here. Now you can see that this cable also had a ground wire, and I'm going to connect this to my engine block to protect my scope. That's everything we need. Okay. Now let's go ahead and lay this on the coils, and then we're going to go to the scope. Now on this this probe has two sides, one to increase and one to decrease the signal. On my homemade, I don't have that. And so I found that on a this GM it's better to go on the side that decreases the signal. So I'm going to place, it says reduce the signal, so I'm going to place this side of my probe on top of my coils. And now as you can see, actually now you can actually bend it. It's kind of nice. You can kind of feed it in between different. There's a lot of obstructions and, you know, stuff in the engine. All right, so I got my my probe on top of my coils, and I'm going to do the same thing on the other side. Now, this is one of the problems, you know, like as I mentioned before, if your probe it's not sitting on the coil all the way down, if it moves a little bit, like here, you can see this gap here, that's going to reduce your signal, and that's what can cause a problem when you're trying to you know, decipher your signal. So that's nature of the beast. There's nothing you can do about it. You just have to deal with it. Unfortunately, that's the way it is. And now I'm going to do the same thing on the bank 2. So this is a bank 1, 1, 3, 5, and 7, 2, 4, 6, and 8. So I'm going to do the same on this side, and go to reduce the signal, and down here. That works great. Okay. Okay. The next step is to make sure none of your cables gonna touch the moving parts, your belt, and your pulleys and stuff like that. So you have to protect your equipment, and so I'm gonna kind of. See, there's something else I don't like about these snap-ons. They're so light. I mean, anytime you move something, they're gonna move as well. So, but It's okay. Alright, so look at that. Now I'm going to find the ground for my ground lead. Put it here. Move this wire away a little bit. Okay, and this one is okay. I think we are ready now to plug in our lead to my scope, and also I'm going to get my second probe, and for my cylinder number 1 and it's all tangled up. Now I'm not really worried where to put this probe. I don't really care about the amplitude of the signal, how I just need some kind of signal, you know, and I can change my voltage and whatever I need to do to kind of stabilize that that signal on my waveform on my screen, on my scope. God, okay, all right. So I'm gonna again take my ground lead, connect it to the ground. Now it's solid. All right, and then I'm gonna take my probe, and see, I don't wanna interfere with my other probe. I'm just gonna kind of lay this on the side and see where it kind of fits the best. I can even put it on a spark plug wire. It doesn't matter. It will still pick up the signal. Again, we're just looking for the current, for magnetic field from our secondary current. All right, so this should work. And if it doesn't, I can always come back and you know, reposition something doesn't look right. But for now, I think this will be okay. And okay, let's go to the scope. I got my scope here, and so dusty. And let's hook up our leads. Now, if I want to, you guys don't see anything. If I want to, I can actually use my regular lead. If it's this kind of short anyway, but they'll be okay. I can use my regular lead. Let's actually do that. It's this kind of annoying. It's a little too short, and let's do this. I don't know how long this video will take. I'm trying to kind of get everything as quick as I can. Alright, so let's go with the blue channel, channel 1. We're going to have our multiple ignition waveforms, and now I'm just going to plug in, hook it up to my snap-on leads. I have to use the back side of my banana adapter. That's fine. And you can see there's some squiggle going on there. That's okay. And then we're gonna have a second channel. And then now we are actually ready to get our waveforms. Now this engine does not have a problem. I just want to show you the setup and how everything actually works. At this point we can actually start the car and set up everything. I can actually go ahead and just activate the second channel. I can use, I don't know, 2 volts and 2 volts here as well. And then now I can increase the time to like 200 milliseconds. That's mostly what you have on the, I think on the V8 you should be able to get all of your, you know, 720 degrees of crankshaft rotation. And alright, that should be it. Let's start it out. Alright, now we can see that our waveform is upside down, which brings me to another question, which people are asking, what kind of scope I'm using, and of course I'm using a Pico, but in order to invert my channel, you can actually go here, I believe, and use this option. Let's see, this is actually built into your scope. Can't even see. There's supposed to be one for your. Oh, there it is. Okay. Secondary ignition probe inverted. So when you go there, you can see now your waveform is where it needs to be. However, I mean, you can use this, there's no problem at all. I really don't see the problem with this. Now you have some kind of imaginary number on your third channel here. It tells you that it's like a 17 kV or something like that, which is pretty close for a for ignition at the idle. However, this is really imaginary number because every coil is different, every card is different. Now you're not getting your ignition waveform from the wiring. You're getting from the top of the coil. So this really, it's not a correct representation of your kV. You can't really rely on that, unfortunately, not any longer anyway. So what I like to do, I use actually, I made me a in this, my library here. I customized and I have inverted on the voltage scale, not the just regular voltage scale. And so the way you do it now, which goes, the reason I wanted to do this is to answer that other question that people ask me, do we need that attenuator? And let's go ahead now. Let's see. Just exactly measure the voltage that we're actually inducing into our scope from that from a this should be fine. And we can now measure the voltage that we are getting from our single pedal. Okay, and it is 1.1 volt. So that's all we're actually getting into the scope. Very low voltage. So there is no need for attenuator. That's why I wanted to go to this channel that I actually made it myself, the inverted channel, just to see the voltage instead of kV. So you can see now we get only 1.1 volt. Okay, so safe for your scope. However, you gotta protect your scope with a special ignition cable in case that you get a breakage in your installation on your coil. And then we're gonna also do the same on the blue channel. We're gonna invert it, and there we go. Now let's go ahead and see actually what is the. Now you can see that of course the frequency of the blue channel is higher because we have multiple cylinders. And when we go down with this voltage, and around actually half a volt. So very, very low voltage on these secondary ignition waveforms. And now from this point you can just let it run, and you can stop and zoom in your waveform, or you can actually change your voltage scale if you want to see it. Now you can actually, now you're playing with your scope, you're playing with your time, you're playing with your now I can see that my blue channel is a little bit too small. Now I'm going to change the voltage to 1 volt. You get a little bit better. See that? Now it's a little bit better. Now I'm going to put this, move this red channel down, and now I'm going to get my trigger. Again, just do this as you go. Don't fuss about what voltage, what time base I should use it. You're going to set it up once you start the car. Don't worry about that. And so I'm going to go to auto. I'm going to go to channel B, there we go, and I'm going to now go to my sync, and then you have 1, 2, 3, 4, 5, 6, 7, 8 waveforms, and you can see this kV is fluctuating up and down. And now we can also change it to 20 milliseconds to kind of zoom your waveform a little bit even more. And that should be 1, 2, 3, 4, 5, 6, 7, 8. You're pretty much having all of the firing events here. Now you can even, with your scope, you can play even more with the Pico. Is awesome. You can actually go here if you want to kind of see your burn time here. You can actually change your vertical resolution. Let's see here. Well, look at that. Look how nice is that with the picoscope. You can change your vertical resolution to actually zoom into this part of the waveform. Do it one more time, and this is how beautiful that is. And now you can actually see the dwell time. You can see the burn time. So a lot of options on the picoscope when it comes to waveforms. You can do you can put your right now I don't need to do a filtering at all. Actually, it's a pretty nice waveforms, and that's about it. At this point, you can do your measurements, looking for the oddball on your cylinder. As I said, this one doesn't have any, but we can now doesn't have any problems. But you can now go and measure your burn time. You can stop your waveform. You can, I mean, there's a million things you can do with a picoscope. You can increase your time base. You can increase your scale here, you know, to get more data basically. And so, like kind of here, you have 2 milliseconds of the burn time. You can now lock it. These two vertical cursors. You can go to next waveform, measure it, compare if it's the same or not. See that? So I mean, there's now, you know, gazillion things you can do. You can of course zoom in even more. Let's see here. There you go. I mean, that's just beauty of the picoscope. I mean, that and that. I mean, so that's the basic setup. I mean, this is what I do, and again, every time I have a chance to you know, get the ignition waveforms, I do it. Let's see what else. What the that's pretty much it. Now let's just go with the firing order. So let's go number 1, number 8, number 7, number 2, number 6, number 5, 4, and 3, and I think this should be correct. One thing I want to show you also now, when I'm using my single waveform, single pedal, just gonna actually turn off this channel real quick. Let's just go to go here. What I like to do when I'm looking at a single cylinder, we're going to go to like 5 milliseconds, I would say 10 milliseconds. This is fine, and you can see here's your you know, single waveform. Alright, so my pedal is on top of the coil, and let's see, I can kind of play with this as well. There you go. Now, what I like to do, at this point, I already have my trigger set up. As I said, I don't really care too much about this spike, this power kV, because it's not always consistent. However, we can always rely on our burn time. So from this point, what I do, I would move this cursor here, okay? At the end of the burn time, I'm not measuring the burn time. You can actually do that if you like. You can actually do this, and now you have like a 2.5 milliseconds of the burn time, you know, roughly. However, many times, because you cannot compare all of the cylinders with this method, you're just going from one cylinder to another. I'm actually going to move this away. What I do have, actually, I have my so to speak, my measure that I can actually compare other other cylinders, other burn time. So this is what I want. If it's this, you know, depends if it's this is a good or bad cylinder. I'm just going to take a cylinder and start from scratch, start from something. So now I have something I can compare it to. Now this line here represents my burn time. So I'm gonna, this is number 1. Now I'm gonna go to number 3. Here's number 3. That's spot on. Let's go to number 5. Spot on. Let's go to number 7. Spot on. So and so and so and so. And so that's the reason I like to do this. If there's you know, some kind of variation in your burn time, you might not be able to see that. You might miss it. You could miss it, but once you set your vertical cursor, then you get something to compare it to, and it works every time for me. If I'm going to have a burn time that is longer or shorter, I'm going to be able to find it. But you have to set up your trigger, and then go with your second vertical cursor, and this works great for me. Just another, and this can be done on any scope, by the way. Various, they all have vertical cursors. That's it, guys. I hope this was not too long. I hope it was informative. I had tried to cover all of the questions that you guys had. As you could see, that our voltage that actually getting into the scope is very low. We're talking anywhere from 0.5 volt to like 1.5 volts. It depends of your equipment. You know, some pedals might get you a little bit higher voltage or lower voltage, but you're still talking not more than I don't know. Maybe I could use this second OTC probe and see what the voltage it is, but it's still low. But you got to be able to have some kind of cable that can actually ground it in case that you have a spike of voltage, and that's I just choose my Snap-on. That's because I have one and I kind of trust it, and I never had any problems at all. And that's it. I mean, you can see that I made my own channel to invert my voltage. You don't have to do that. You can. It's actually pretty easy. You just go to setup. You go times -1, and it's going to invert your channel. It's pretty simple. But you don't have to. You already have that set up in your picoscope. You just go to your kV. However, don't trust that kV scale, because that's not a true representation of your actually kV. You would expect to have, you know, like around 12 to 15 kV at the idle, but that may not be correct. You're going to have some kind of a scale, but nature of the beast nowadays is you're not getting your waveform from a wire, you're getting from the coil, and it's going to be different. So don't rely on that power kV anymore. You don't. Now, if you have a spark kV, you can. The spark kV, if it varies, you know, that's indication that you're going to have a problem with your primary primary ignition waveforms. Now, there's a million stuff around. I mean, I don't want to go into, you know, how to decipher different waveforms. This is just a setup, how I use it, how much time it takes me to set up everything. You could see, I don't know, maybe 10-15 minutes. And again, more you use, more comfortable you will get with it, and that's it. I mean, I really enjoy the secondary ignition waveforms. Anytime I have a chance, I'll do it. And if you guys have any more questions, I'll make number 3. Just let me know. Thank you so much, and see you next time. Bye-bye.